Hi, welcome to lesson 3.5, dividing polynomials. Well, first, before we start dividing polynomials, I think we should take a little trip down memory lane and learn how to long divide one more time. I believe people use their phones a lot to divide, or calculators, so let's see how we used to do it back in, when was that, grade 3 or grade 4, or whenever we divided? Okay, so we're going to start off by looking at 3,576, and we're going to divide that by 4. So the way I learned how to do it is I put the 4 out here, and then the 3,576 here, and a little bracket like that. Okay, so first you start off and say, well, how many times does 4 go into 3? Well, 4 doesn't go into 3, so we have to move on to the next digit then. So how many times does 4 go into 35? Well, 4 goes into 35 8 times, so I'll put that above 5. And then I do 8 times 4 to give 32, and then I'm going to subtract. And when I subtract this, I end up getting 3, bring down the 7. Now I say again, how many times does 4 go into 37? And that, again, would be 8. No, 9. There we go, 9. And then 9 times 4 is 36. I write that down below here. I subtract, and I get 1. Then I bring this 6 down, and I say, how many times does 4 go into 16? And the answer is 4. 4 times 4 is 16, so I subtract that and get a remainder of 0. Okay, so that's how long division works back in elementary school. Now we're going to look how long division works with polynomials. We've added polynomials before, we've subtracted, we've multiplied, and now finally we're going to learn how to divide. So same sort of idea. I'm going to have x minus 4 out here. I'm going to write 3x cubed plus 5x squared minus 7x plus 6 underneath the bracket, or the division symbol, I guess. So this thing here, that's called the divisor. This is called the dividend. And when we're finished, up here, we're going to be writing the quotient, which is, of course, the answer to a division question. And if there's anything else left over, we'll write the remainder right here. Okay, so now comes the big question. Now, what do you do with that x minus 4? Over here, we just had a 4, and we had to see how many times 4 went into 3 or 4 goes into 35. Well, because we've got x minus 4 here, we can't really involve both of them. So the most important thing to start with is just the x. Okay, the negative 4 just kind of comes along for the ride, and you'll see how that works out. So I'm just going to focus on the x, and I'm going to say, well, what do I multiply x by to get 3x cubed? So you think for a second, what times x gives me 3x cubed? We have to go back to power laws, and when you multiply powers, remember we keep the base the same and we add exponents. So x times 3x squared, and I'll write that over the 5x squared, just because it's common, those are like terms. So if I multiply 3x squared by x, I would get 3x cubed. And then I'm also going to multiply this 3x squared by negative 4 to get negative 12x squared here. Okay. Then, because there's two terms here, and as you saw here, with that first example, division is just multiple subtractions, just like multiplication is no more than multiple addition. Okay, so division is multiple subtractions. So I'm going to subtract now, and I'll put brackets around that. And then I subtract. And I say 3x cubed minus 3x cubed, well, that's 0. Then I do 5x squared minus negative. So that minus negative will then become a plus. So 5x squared minus negative 12x squared then gives me 17x squared. Okay, I'm going to now bring down this negative 7x. And I go back up here again and I say to myself, what multiplied by x will give me 17x squared? Well, we see the 17 is positive, so we're going to have a positive here. And 17x times x will give me 17x squared. So I'll write this 17x above the like term there of negative 7x. And then I multiply 17x times x, get 17x squared. And then 17x times negative 4, and that gives me negative 68x. Okay, I'm going to subtract after I put brackets around that just to make sure I get all the signs correct. And 17x squared minus 17x squared, well, that's just going to give me 0. And that's the idea. You want to get rid of that first term. You're going to eliminate it. And then negative 7x minus negative, again, so that would be negative 7x plus 68x. And that's going to give me then 61x. Again, I bring down this last term now, plus 6. And then I go back to this again, and I say, well, what do I multiply x by to get 61x? And that would be a plus 61. And then again, I multiply 61 times x, I get 61x, which is what we need. We want that to eliminate. And 61 times negative 4 would be negative 244. Again, I'm subtracting. 61x minus 61x, again, is 0. And 6 minus negative, again, so 6 plus 244 gives me 250. So my remainder is 250. Okay, and I know that's the remainder because there's nothing else up here to bring down to continue dividing. Okay, and there's no x here beside the 250, so there would be nothing that I could multiply the x by to actually get 250. Okay, without getting into negative exponents, and we don't want to do that anyways because we want to keep this as polynomials. So all the exponents on the polynomial would be whole number exponents. Okay, so we wouldn't get into the negatives anyways. Okay, we're going to go through a couple more examples, so don't be alarmed here. All right, so one thing that we can do now, and I'll bring this up a little bit closer so I can see the answers we just wrote. So in order to check division answers, just like if we're checking maybe addition questions, we would subtract, or if we check multiplication questions, we would divide, just to kind of see. We do the opposite to check to see if we're all correct. So what we're going to do here to check if these divisions are correct is we're going to do the opposite process. Okay, so here we divided 4 into 3,576 and got 894, remainder 0. So now if we were to multiply 4 times 894 plus the remainder, we should get that 3,576. So here's my divisor. I multiply by the quotient. I add the remainder. And if you'll believe me, 4 times 894 plus 0 is 3,576. So we'll do the same thing here. What we're actually writing here is called the division statement. Okay, and sometimes that can be very helpful in order to solve other items, other components of this division. So here we've got the divisor, here's the quotient, there's the remainder, and there is the dividend. So if we do the same thing here, we write out our divisor, which is x minus 4. We multiply that by the quotient, which is 3x squared plus 17x plus 61. And we add the 250 for the remainder. And that's going to give us the dividend, which is 3x cubed plus 5x squared minus 7x plus 6. Okay, so the divisor multiplied by the quotient plus the remainder equals the dividend. Okay, I'll put a little multiplication symbol in there. Okay, so that's the division statement, and that can be used to check your final answer. Okay, so if we were to, what we should have done, instead of just writing out the dividend, I should have expanded this all out. Multiplied all this together, simplified it, added the 250, and I would indeed have gotten this dividend here. Okay, so let's move along here. We'll go to the next couple questions. We want to divide these and write the division statements. So we're going to take a look at this. And so here's our divisor, because we're dividing by that. So that's the divisor. So we've got 2x minus 3. There's our dividend. So we got 2x to the power 4 plus 7x squared plus 3x minus 5. Okay, and we're going to then divide here. So I want to find out, I ask myself again, just from that first term, we don't look at the negative 3 at the moment, but I say, what do I multiply 2x by to get 2x to the power 4? And I see that that would be x cubed. Well, I see that I need to put the x cubed here, but that's not above, there's no x cubed down here. So that, I'm going to see what's happening here. There, the last question we had, there was an x cubed, or, the part of the quotient was above a like term, and I don't see that right now. So I'm going to have to be aware of what's going on here. So if I multiply x cubed by 2x squared, or 2x, I get 2x to the power 4. And then I multiply x cubed by negative 3, I get negative 3x cubed. Okay, so if I now subtract this, I see I don't have like terms here with that 7x squared and the negative 3x cubed. So the like terms aren't there, so I can't actually subtract this. So if I were going to subtract, I'd end up having extra terms that I can't put in here. So in order to get a like term here, I'm going to actually have to put in a placeholder. See, it goes from 2x to the power 4 in the dividend to 7x squared. So there's I'm missing that x cubed term. So what I need to do is I have to actually put in a placeholder to make sure I have all the correct descending powers of x. So I've got 2x to the power 4 plus 7x squared, but what I don't have in there is an x cubed. Okay, so if I don't have an x cubed in there, how many x cubes would be there? So if it's not there, it's got to be 0x cubed. So I need to write in a 0x cubed in order to perform this. And then I just continue with the 7x squared plus 3x minus 5. Okay, so we have to go down in descending powers of x without skipping any powers. Okay, once I've done that, now I can go ahead and subtract 2x to the power 4 minus 2x to the power 4. We get 0. 0x cubed minus negative 3x cubed. So we got the like terms, so we can do this. So 0x cubed plus 3x cubed, we got 3x cubed. Now I can bring down the 7x squared, and that gives us, we've got that descending power of x, so that'll help us continue the division. Now I say, of course, 2x, what do I multiply 2x by to get 3x cubed? Well, 2x, now this is a little trickier because I'm not going to be using decimals. So 2x multiplied by something gives me 3x cubed. Well, I know it's going to be an x squared, but 2 multiplied by what will give me 3? So what kind of fraction can I have there? 2 multiplied by what will give me 3? So I'm trying to multiply by something to get 3. Well, there's a 1 in this denominator here, and there's a 1 here. Well, the only thing that can cancel out that 2 would be perhaps to have, and we need a 3 here, so we can cancel out that with a 2, so 2 over 2 is just 1. And if I have a 3 here, so we have 2 times 3 divided by 2 gives us 3. So that's 6 divided by 2 gives us 3. So I have to multiply this 2x by 3 over 2 x squared to get that 3x cubed. Okay, now I'm going to go back and multiply. So 3 halves x squared, 3 halves times 2 gives me 3, and that's x cubed. Then 3 halves x squared multiplied by negative 3, I'm going to have negative 9 halves x squared. Okay, so things are not looking as cute as they were before. It's a little bit more ugly with these fractions, but we can do that. 3x cubed minus 3x cubed is 0. 7x squared minus negative, so 7x squared plus 9 halves x squared. So I know I have an x squared here. And 7 is the same as 14 over 2. So 14 over 2 plus 9 over 2 gives us 23 over 2 x squared. Now we bring down this 3x here. And I again go back to the well again, and I say, well, what do I multiply 2x by to get 23 halves x squared? Well, I know there has to be an x, and it has to be positive because that's positive. So I've got an x in there, and I've kind of messed up the spacing, but that's supposed to be above the 3x here because they're supposed to be like terms. And so 2 times what gives me 23 over 2? Well, that would be 23 over 4 x. And then 23 over 4x times 2 will give me that 23 over 2 x squared. 23 over 4 times negative 3 is negative 69 over 4 x. Bracket, subtract. 23 halves x squared minus 23 halves x squared, that just disappears. 3x minus negative, so again plus 3x plus 69 over 4. So 3 is 12 over 4 plus 69 over 4, which gives us 81. Whoops, got to change the color here. It gives me 81 over 4x. And the last thing we have to do is now bring down this negative 5. Again, same sort of idea. We have to now multiply or find out what do you multiply 2x by to get 81 over 4x. And that would be 81 over 8. And 81 over 8 multiplied by 2x gives me then 81 over 4x. 81 over 8 times 3, negative 3, is negative 243 over 8. I subtract 81 over 4x minus 81 over 4x is 0. Negative 5 minus negative, so negative 5 plus 243 over 8. Well, 5 over 8, or 5 is written as a fraction over 8 would be 40 over 8. So negative 40 plus 243 gives us 203 over 8 as the remainder. Okay. All right, so we've done all that division. That's a bit of a pain with all the fractions, but it's necessary to kind of see how some of these questions can be involved. And we want to write the division statement for this. Okay, so we're going to take the divisor, multiply by this quotient, add the remainder, and that will equate it to the original dividend. Okay, so for our division statement, we've got 2x minus 3 as the divisor. The quotient is x cubed plus 3 halves x squared plus 23 over 4 x plus 81 over 8 plus the remainder, which is 203 over 8, and that's going to equal the original dividend of 2x to the power 4. You could write in the 0x cubed at this moment, but you don't really need to because we've used that placeholder in the division. So you can just write the plus 7x squared plus 3x minus 5. Okay, divisor multiplied by the quotient plus the remainder equals the dividend. Okay, all right, so now that we've done a few examples, what I'd like you to do is, can you please try this example by yourself, pause the video, and try this one, and then I will go through it to help you see that you are correct in your work. Okay, so I see that you have worked out the division. So we get x plus 1 as the divisor, and we wrote 5x cubed minus 4x squared minus 4x plus 1 as the dividend. And now we do our usual dance here. What do I multiply x by to get 5x cubed? So that would be 5x squared. So then 5x squared multiplied by x is 5x cubed. 5x squared times 1 is 5x squared. I subtract this. 5x cubed minus 5x cubed is 0. Negative 4x squared minus 5x squared is going to be negative, whoops, let's go blue, negative 9x squared. Then I bring down this negative 4x. And And what do I multiply x by to get negative 9x squared? Well, that would be negative 9x. Multiply negative 9x times x to get negative 9x squared. Multiply negative 9x times 1 to get negative 9x. Subtract negative 9x squared minus negative 9x squared. Well, that gives us the 0 pair. Negative 4x minus negative 9x is negative 4x plus 9x. That gives us 5x. Sorry, I keep forgetting to change the color here. So that gives me 5x. Sorry, that's supposed to be an x. And I bring down this 1. One more time. What do I multiply x by to get 5x? That would be plus 5. 5 times x is 5x. 5 multiplied by 1 is plus 5. And we divide, or we subtract 5x minus 5x is 0. 1 minus 5 is negative 4. So we have a remainder of negative 4. Okay. And so then hopefully you've found that you have divided correctly and you have that quotient and remainder. So then for the division statement, we've got x plus 1 multiplied by the quotient 5x squared minus 9x plus 5 plus the remainder, which is negative 4, so I can actually just say minus 4. And that equals the dividend, which is 5x cubed minus 4x squared minus 4x plus 1. Okay, so usually we title it, we just kind of announce what we're doing. So here's our division statement. Divisor, quotient, you don't always have to do this. Remainder and dividend. Okay, so hopefully you got that correct. All right, so now we're going to do something almost completely different. We're now going to use short division. So short division in polynomial division is called synthetic division. And I'm going to show you, let's go back to the very first example with that 3,576 divided by 4. Well, this long division takes up a lot of space, and we're writing everything out. Short division does exactly the same thing, except for a lot of the stuff you do in your head, a lot of the calculations. So I'm going to say, okay, well, how many times is 4 going to 3? It can't. 4 goes into 35 8 times. 8 times 4 is 32. 35 minus 2 is 3. So I write the 3 here. Then, how many times is 4 going to 37? 9 times. 37 minus 36 is 1. And 9 times 4, 4 times 4 is 16. So we get the remainder 0. Okay, so here's that remainder 3 here from that first subtraction. And then here is that 1 from the second subtraction. And then, of course, here's our 0 for the remainder. Okay, so we're going to be doing the polynomial equivalent to short division. And that is called synthetic division. Okay, so what we do here is we take a look at what the divisor is, and we take a look now at the second term of that divisor. And now instead of using the -4, we're actually going to use the +4. And what that does, if we use the +4, that allows us to do some adding instead of subtracting. Okay, so sometimes adding is a little bit easier. So we're going to draw an L bracket, and we're going to put in all the coefficients that we see here and the constant. So we got 3, 5, -7, and 6. Okay, so this is the initial setup. So notice that the sign of that, the x minus 4, the sign of the 4, is going to be the opposite when we put it out here. So we're first just going to drop down this 3, and then we're going to multiply 4 times 3 and put the answer here. Then we're going to add down 5 plus 12. Then we're going to do 4 times 17, and I believe that's 68, if I'm not mistaken. And then from there, we're going to add -7 plus 68. So that's going to give us 61. Then we're going to multiply 4 times 61 to give us 244. And then we're going to add down, and that's going to give us 250. Okay, so this last term that you always have here, that's the remainder. And because we're dividing, so now what we're going to do is we're going to write out, like if this is a polynomial here, actually, I guess we'll write out the division statement again. But that, because we're dividing this 3x cubed, like this cubic, by a linear, remember that has a power of 1. So when we divide an x cubed by an x to the power 1, well, if you're dividing powers, that's just going to give you x squared. Okay, so that 4 represents x minus 4. So there's our divisor. Our quotient is going to be 3. That's the coefficient. But instead of x cubed, it's going to start at x squared because we already divided. So here we divided the x cubed by the x to the power 1, and that gives us the exponent 2. So that's why we get the squared here. And then the rest of these, the 17 has the next lower power of x, and then the 61 is the constant. And then we got the remainder, 250, and just out of lack of space here, I'm going to put the quotient, or the dividend under here. So then we just have the dividend, just as we always would. Okay, so we always start with one power less because we've divided by a single power of x. So that's why the power decreases by 1 when we start off with the quotient. All right, let's try this again. We've got 2x to the power 4 minus 3x squared. Well, here again, we're missing that 0x cubed. We have to add that in, okay, like we saw before. So we just have to put in that placeholder. So x plus 3 is what the divisor is, so we're going to divide by -3 in the synthetic division. It's the opposite sign. And we're going to put in all these coefficients. So 2, 0 for the x cubed, -3 for the x squared, -3 for the x, and -4 as the constant. Okay, we start by bringing down the 2. Then we multiply -3 times 2, put the answer here. Then we add down, 0 minus 6 is -6. -3 times -6 is positive 18. Then we add down again, and we get 15. -3 times 15 is -45. add down again, we get negative 48. Put the answer up here. No, sorry, negative 3 times negative 48. Negative 3 times negative 48 is 144. And then we add down again. Sorry, wrong color. Got to keep things consistent. 144. And then we add down again and get 140. Okay, division statement. We start off with the divisor, x plus 3, multiplied by the quotient. So we started at 2x to the power of 4, but we divided by a single power of x. So that 2 is going to be the coefficient of an x cubed term. So it's 1 degree less than the initial dividend. And then negative 6, and then we just decrease in powers of x. Negative 6x squared plus 15x minus 48, that's the constant, plus the remainder of 140, and that's going to be equal to the dividend of 2x to the power of 4 minus 3x squared minus 3x minus 4. Okay, the synthetic division saves a bit of time. Okay, and that's it for synthetic division. I'm going to check a couple little problems here. The dividend below, here's our dividend. The dividend was divided by some other polynomial, which we don't know. Of course, that would be the divisor, resulting in the given quotient and remainder. We want to find that other polynomial, so the divisor. So we're given all these parts. And so this is where the division statement really comes in handy. So the division statement, remember, was the divisor multiplied by the quotient plus the remainder equals the dividend. Okay, so if we actually, before putting all this stuff in, so we've got the dividend. Okay, we've got that taken care of. We've got the remainder. We've got the quotient. So it looks like we're going to be looking for the divisor. Okay, so here's an equation that we have to rearrange now. So we would subtract the remainder from both sides. So we're going to be left with the divisor multiplied by the quotient equals the dividend minus the remainder. And then to get the divisor by itself, we have to divide both sides by the quotient. So we're going to be left with the divisor equals the dividend minus the remainder all over the quotient. Okay, and these are all parts that we know. We got the quotient here, we've got the dividend, and we've got the remainder. So then we just put all this stuff together. So the dividend is 10x to the power of 4 minus x squared plus 20x minus 2 minus the remainder, which is 99,698. And we divide that by the quotient, which is 10x cubed minus 100x squared plus 999x minus 9,970. Okay, so because of all this mess that we have here, it's not just a simple binomial that we were dividing by when we were using synthetic division. So because it's not a binomial, we have to do this the long way and do the long division. So here's the dividend. I'm going to put these two constants together. So I've got 10x to the power of 4 minus, well, we need a 0x cubed here. I'll put a plus there. Minus x squared plus 20x And minus 2 or negative 2 minus 99,698 would be 99,700. Okay, and we're dividing this by all of this. I'm going to load it from this end just so I have enough space, if I can squeeze it in. So I started from the left. Who knows if I would be able to squeeze it all together. And 10x cubed. Okay. So we're dividing this dividend minus the remainder by the quotient. And when we divide all this out, we should get the divisor. Okay. So same thing goes. I just look right at the very front, the very first term. What do I multiply 10x cubed by to get 10x to the power 4? Okay, well, that would be x. I'm going to put this way over here above the x term. Now I multiply x by each one of these terms and put them down here. So I have 10x to the power 4 minus 100x cubed plus 99x squared minus 9,970x. Put brackets around it and subtract. And I subtract here. So 10x to the power 4 minus 10x to the power 4, which is 0, which is what we want. 0x cubed minus 100x cubed, or sorry, minus negative, gives me positive 100x cubed. Negative x squared minus positive, so negative x squared minus 99, which is negative 100x squared. 20x minus negative, so 20x plus 9,970 would be 9,990x. Bring this negative 99,700 down. And then we try again, and we say, well, what in the world do I multiply 10x cubed by to get 100x cubed? So 10 times what gives me 100? We've got the x cubes already. So I've got 10. And then I multiply. 10 times 10x cubed is 100x cubed. 10 times negative 100 is negative 1,000. X squared. Then I have 9,990x, sorry, 10 times 99x, which gives us 990x. And 10 times negative 99, or 9,970, sorry, 99,700. Again, subtracting. And 100x cubed minus 100x cubed is 0. 100x squared minus 1,000x. Did I make a mistake? I think I might have. Okay, well, I see that I made a mistake a long way back up here. That 999 was supposed to be that 99x is supposed to be 999. Same thing goes here. And then that would be 999 there, which should give us 1,000 here. There we go. Okay, now things, I believe, are starting to fall into place. Another 9 there. There we go. Okay. Now we're getting back into normalcy here. Sorry about all that. So now we pick it up where we left off. 100x cubed minus 100x cubed is 0. Negative 1,000x squared minus negative, so plus 1,000x squared is 0. 9,990x minus 9,990x is 0, and 99,700, sorry, negative 99,700 plus 99,700 is 0. Okay, so the remainder is 0, and our dividend is x plus 10. So the dividend of the original question which we're looking for is x plus 10. Okay, sorry about that mistake earlier, but these things happen at times. Okay, and now I'm just going to do one final example here. We've got a volume of a cylindrical can being 4 pi x cubed plus 4 pi x squared plus minus 55 pi x minus 100 pi centimeters cubed. The can is x minus 4 centimeters high. We want to find out what the radius is. Well, first of all, we have to realize that the volume of a cylinder is pi r squared h. We need to know the radius. We have the height. We have the volume. Pi is a constant, so we can sort of figure this out. So we need to find the radius. So I'm going to divide both sides by pi h to isolate the radius. So we've got radius squared equals 4 pi x cubed, here's the volume, plus 4 pi x squared minus 55 pi x minus 100 pi. And that's all divided by, well, pi h, well, pi, and h is x minus 4. All right, so first things first, I see that in every term here, there's a pi, so that will just simplify down with a pi there. I could have factored the pi out, but that's an extra step I'd like to avoid. And the radius then, well, we got to divide. So x minus 4 divided by this. You know what, I'm going to do synthetic division just to keep it a little bit simpler and quicker. So we're going to divide by 4, and we have 4x cubed plus 0, nope. 4, again, negative 55, and minus 100. And I'm going to bring this down first. So we got 4. 4 times 4 is 16. Then I add and get 20. 4 times 20 is 80. Then we're going to add down to get 25. Then 4 times 25 gives me 100. Then I add down and get 0, which is great because the remainder is 0. So then I can say, well, here's the remainder. So r squared, or sorry, the quotient is 4x squared. So see, we started with an x cubed, we divided by an x here. So that gives us 4x squared plus 20x plus 25. Remainder 0, so we don't really actually even have to write that. And a keen eye would see that that 4x squared plus 20x plus 25 is a special type of factoring. I see that first term is squared, that last term is squared, so that could be 2x and then plus 5. The key, though, is I have to multiply these two together, 2x times 5 to get 10x, multiply that by 2, and I see I do get that middle term. So this is indeed a perfect square trinomial. So r squared is 2x plus 5, all squared. Take the square root of both sides, so r is 2x plus 5. Okay, so the radius of this cylindrical can is 2x plus 5 centimeters. Okay, so that is, in a nutshell, your introduction to division of polynomials. And here's a little bit of fun that you can use to consolidate this information. And I will thank you very much for watching, and we'll see you in class.